Hello everybody, my name is Thomas from Simi Reality Motion Systems, and today with me is Stephen Pickard from the Institute of Applied Training Science, one of our clients.
Hey guys.
And yeah, today we want to show you some possibilities in using our motion capture technology in the field of Olympic elite sports. First of all, I want to give you a quick introduction, overview about our company. We are a German company based in Munich, and we are developing Markerless Motion Capture Technology since more than 27 years now. Our systems are optical systems, so they're mostly based on these kind of high-speed cameras. They're sometimes in housings, so if we have customers who want to use the system outdoors. And our expertise is in tracking markerless, so it means our tracking systems are not using any markers or sensors that we have to attach to the human body. First of all, we have a motion capture platform, so it's very important to say it's not limited to a specific kind of motion or a specific kind of sport. It's a general motion analysis system which is able to be implemented into any kind of sport to make it very flexible in the overall use in the elite sports. And normally we are also providing the motion capture platform, so it means a specialized camera system which will be calibrated to a sub-millimeter accuracy that our customers then can use to really get very accurate data for the data analysis, which is necessary to do biomechanical studies. Our systems are sometimes installed like here in baseball stadiums or outdoor scenarios to really make a very easy use in different applications, but we will have to take a look into that project together with Stephen in the future of that presentation. Here you can see an installation, so you see that there are several cameras installed which are here installed at a tennis court, and they can capture the entire game, and we are rendering out a 3D biomechanical model from the athletes to get very precise information about joint angles, joint positions, about the velocity of the joints and the racket, for example, to understand the athlete's movement in a much more detailed way than the normal eye of a coach can do that. So Stephen, can you quickly tell me something about who you are, where you work on, what is the Institute of Applied Training Science? Maybe give me a little introduction about yourself.
Yeah, Thomas, thank you. I'm working here at the Institute of Applied Training Science. I'm a co-worker in the biomechanics section. We work on different diagnostic systems which related to strength platforms and different measurement systems that we use in every Olympic discipline in our laboratory or here in the gym and also in the fields.
Okay. So how do you normally use the system in your scenario? So you told me about something in training. So how often do you use that in training? Is it just once a year or?
It's a regular multiple time a year sessions of training and diagnosis and during the competitions, but also in normal training sessions.
Okay, but you also track during the competitions, right?
Yes, in world-class competitions multiple times a year, yes.
Okay, and can you quickly tell our audience here why do you use it for competitions? Is there something, some more information you get out related to or compared to a training analysis?
Yeah, we check the performance of every athlete in the Olympic disciplines during the year to check their performance level and the parameters that are really had the highest priority during the movement. And we check that also during the competition to see how their performance level is at that point, a year or in the season.
Okay, cool. So maybe we'll just make a little introduction about what you have from us.
Yes.
So you have a camera system from us, right?
Yes, we have the Simi shape system, which are 8 camera system with a huge PC and monitor, and we use this system in, for example, throwing disciplines in ski jump and outdoor. Also more technical disciplines like figure skating or snowboard, diving. Yeah.
Okay. So when I understand that correctly, you have a mobile system, right?
Yes, you have a static system here at the institute, and also a mobile system where we are able to use these measures wherever we want.
Okay. So you just go to the training place or to where the competition takes place, and then you go to install the system the day before, maybe?
Yes, several hours before the competition starts. It's maybe enough to get a good start. Yeah.
Okay, so it's very quick and easy for you to set up.
Yes,
you as it expertised.
Yeah. if you've done it a lot of times, you get it quicker. Yes, it's easy to install when you know how to install it the right way and get a good setup.
Okay.
It relates on the times you've done it before. Yeah.
Okay. So, and is there anything special about the cameras we have here?
It's better than the older technique we got here. It's the newest camera technique we got here at the institute. We are able to measure movements with the highest frequency, and that helps us to get a detailed view in every movement section, every detail we want to have during the motion.
Oh, okay, very interesting. So, Stephen, you brought some examples with you today.
Yes.
That we want to show, so to give the audience a little information about how is it looking like when using a markerless tracking technology. But first of all, I want to have one last question, theoretically.
Yeah.
So, why are you using a markerless technology and not, putting sensors on the body or markers? Is there any value you see from having a markerless tracking technology?
Definitely, yeah. It's we want to give the athletes the most free and normal feeling they have doing a competition or a training. So it's not the best way to let them move in their environment with some attached markers. So we use the markerless system to let them move like they always do, and we have also some advantages doing the analyze afterwards.
Yeah. Of course, and in the competition you cannot use sensors, right?
Yes, also, that's also a problem that we can use markers during an official competition.
Okay, cool. So let's take a look into a project.
Yes.
So can you tell me a little bit about what we see here? So
yes. This is an example of a discus thrower. We measured it here at the institute. It was an official training, and we do these training sessions to check technique and have a detailed look and specific parameters during the throw and during the whole motion. Have a special look at the velocity of the throw of the discus or javelin or shot put or whatever. And this is one of the main aim to create the highest capable velocity of the discus in the end of the last point of touch.
Okay, and can you tell me a little bit about how that works in real time?
Yeah.
Like the athlete is coming into your training facility, and do they have to prepare something? Do you have to prepare the athlete, or how is it normally like how much time do you spend with the athlete during the analysis?
Okay, normally we didn't interact that much. The athletes come, we installed the system right the day before, so that is everything right at the start when they start throw.
Okay.
And when they are ready, they enter the circle and just let it throw.
Okay, and then you have the markerless tracking, which automatically gives you all the kinematic data.
Afterwards, we put it into the shape system and do the whole tracking of the complete motion from the very start to the last point of touch. and then we look at the results and give a feedback.
Okay.
Yeah.
And then together with the trainer, I think you will discuss about the specific parameters.
Special angles or special positions of joints or something else. Yeah.
Okay. So what do we see here in that graph, for example? What are the red line? What is the black line here?
Okay. The black line visualizes the trajectory of the discus during the whole motion, and in relation to the center of gravity in the motion.
Okay, and this seems to be a very crucial parameter for a discus thrower,
yes,
right?
Yes, the trajectory shows where the arm is related to the center of gravity.
Okay.
And in the relation to the feet. So we have a special look on this. Yeah.
Okay. And what exactly is the shape system, the Markerless tracking? What kind of parameters do you get from the system?
Nearly everything. We got multiple joints that we can analyze afterwards, but also angles, velocities, accelerations, torques. We can put a lot of things out there. Yeah.
Okay, cool. And also, what is this graph here below? So what do we see here with the blue line here?
Yes, this is the velocity of the discus. So it should be at the highest value at the end of the throw.
Okay.
So this speaks for a good and a long throw afterwards.
Okay.
Yeah.
And I guess the other one is the shoulder elevation.
Yes.
Which
on this parameter we can see at which height and in which direction the shoulder is moving through the whole motion, and we can give advices to bring it a little bit longer from the center of gravity or a little bit lower.
Okay.
So given some advice to increase the velocity of the discus.
Okay, and then you have this very important to have this continuously done during the training over the time over year, because of course training is changing a lot and the athletes are changing.
These are young starters, so we give them a continually check on their technique, so that they get better and reach that Olympic elite level. Okay,
cool. So this was one example from the training, which is quite amazing from my perspective. And let's take a look into one other example.
Yeah, for sure.
Okay, Steven. So what do we see here in that example?
Okay, this is an official competition measurement and a video from a ski jump in Klingenthal last year. It's an official jump in the competition where we set up also the system a day before and check their performance during an official event.
Okay, so what you're searching for is all maybe differences between the training and the competition, so how the athletes perform in different scenarios, right?
In different conditions, right?
Okay, because this is a very parameter that's very influencing, and in the end the competition counts for the athletes, right?
Yeah. You have to be on the highest level of your performance when it counts on a competition of an official event, Olympic Games, whatever.
Okay, cool. And so here we have 8 cameras installed at the ramp, and they're capturing with 250 frames per second.
Correct.
Yeah, which will give you a very detailed, right? Because they drive down with 90 km per hour.
Yeah, it's just in 1 second video. It's just 1 second. It's not able to catch an eye.
Okay, so we have it really in slow motion, and the trainer can also look at the video, right?
Yes, they check all the 8 views of this motion in different angles and look at the 3D model afterwards. So they get a lot of details only to see on this video views, not see any parameters.
Okay. Yeah. And what do the trainers say? They're not used to, it's so fast, and everybody who was watching ski jumping competitions knows that you don't see something with your eyes. So that's very important to get some quantitative data now on these amazing fast movements. from that competition. So what kind of parameters do we see here? So in the video, there are, it's an overlay, right? So what is that for an overlay?
These are all the joint centers together, get together in one model. So we can see the whole phase of takeoff from the kneeling position up till the upright position in the end, before they get over into the flight system and the flight position.
Okay.
Yeah.
And the green line here is the center of gravity.
Yeah, correct.
Velocity.
Velocity. Yeah. We think that this is a parameter that is high on. Yeah. One of the parameters we look at if we want to know if this is a good jump or a jump that is very far. So this is a parameter that really is related to this result in the end.
Okay.
So if this velocity of the vertical velocity of the center of gravity is high, so we can accept, or we can accept the high and also a far jump.
Okay.
Yes.
So normally, what you measure, for example, in a lab, in a biomechanical lab, and you have like force plate underneath, and you have a motion capture systems. So you're transferring that to the ski jumping ramp.
Yes.
Because it's, you cannot transfer that motion into a lab environment. So that's why it's so important to get that from the competition.
If you are able to track also the strength measurements, the force power of the takeoff, we can put both together and have a more detailed look at the takeoff analysis.
Okay, cool. And what are the lines below here? So the blue line and the
purple,
this green line.
Yeah. This is the knee angle,
okay.
Left and right side. So we look at this whole movement and check on the angle here.
Okay.
So it should be around 140 degrees at the last touch of the ramp. So
okay.
the takeoff point should be around 140 degrees.
Okay, so what we see here right at the corner at the edge of the ramp is around 150 degrees. So it means he's like a little bit too late.
Yes, that means he stepped through. He stepped through the jump because this is higher than 140. So this means this is a little bit late. So this is not the optimum of a good takeoff.
Okay.
He should take more focus on a better timing.
Okay. Okay. And then you can, of course, you do that continually during the training and competition,
yes.
So you can see how an athlete, or especially the youth athletes, how they are evolving in their performance.
This is also a youth competition.
Okay.
This was in last year. Yeah.
Okay, and of course, maybe you can compare all the youth athletes to the elite athletes, and
yes, we can compare the data.
Okay.
Definitely, and we have some good elite jumpers, so we can give advices and some good tips to get better and reach that level of performance.
Okay, cool. And that's, I think, a very good example of how to use our markerless tracking systems in either a training competition in a daily environment to continuously follow up the movements of athletes during the training, but also to have the results compared to the competition, where it counts, where you have to 100% performance, and where you can see if the training was actually successful. Because without having the data from the competition,
yes.
you would not know if it's possible.
Yeah, and the absolutely advantage in this system is you don't have to do any manual steps. Normally we had to click manual by hand every single frame, so it takes a lot of time to analyze one single jump. So with this system we can compare a lot of jumps after and after, so we have a much more database for our results. Yeah.
Okay. And maybe one last question, because that's maybe also interesting for the audience. So are you using the system in these kind of scenarios, or are there also complex type of sports where you are using the system, like gymnastics or something like that?
Yeah, we use it in a few technique compositoric disciplines like diving which we also can do here at the Institute, and we all has done before. Also figure skating, which is also here, took here place, and also is able to install the system on ice.
Okay.
Yeah.
Okay, cool. Yeah, because that's very interesting that you also use it for mostly the technique related sports,
Yes.
where this is so interesting to get data on.
It's such an advantage to bring the system to the normal environment on every athlete. So you don't have to measure it during laboratory positions and laboratory environment. You can do it out there in the field. So they feel comfortable, they do what they always do in training or in competition, and you can have a detailed look on it.
Okay.
Yeah.
Very interesting. So thank you very much, Stephen.
Yes.
We both are here for a couple of minutes then, I think, for answering questions. If you have questions, then come back to us, and we wish you a happy and joyful presentation for the conference, and thanks.